All right, Sasha, hopefully you feel better. All right, so we just have to pay attention. The n is my root. The m. Now, what's the difference? That's kind of a bad way to ask this question. Why do we have this written in two different ways? Why do we have the nth root of a to the m or the m power of a to the nth root? Emily? So it's really a to the m to the 1. So Emily's saying we could write this as a to the m to the 1 over n. Yeah? So what does that support? Your first one here or your second one? Leon?
They're both basically the same because for a to the m to the nth root, it's basically a to the m times this nth root. Okay, I'm confused now. Okay. Okay, so a to the nth root. Okay, never mind.
Jacob?
So, are you asking like why they're the same?
Yeah. Like
Okay.
why we have two different ways that it's expressed.
Oh, what they're. Well, like for the first one, it's really a to the m, a to the m times, times, to the power of.
Like what Emily had said?
Yeah, that's the first one. And then the second one is kind of a to the 1 over n, and then to the power of n. Like.
Okay. So it will make more sense why we use the two different representations as we look at some examples. I want you to sit on the fact that those are the same, they just look different and they're used for different situations. So like the first situation that we see here deals with the third root of 125. What is the simplified form of each expression? So we want to write them, oh come on, catch up with me.
Dude, I had it. Wait, I had it first.
All right.
Dude, I had it.
So you guys can go ahead and try those first couple from problem 1 while I log back in because Pearson hates me.
Oh yeah, I got that answer too. Thanks to my
Stop using your calculator. Try to use your brain to do these things.
I got shot at 10. I don't
All right. So when we're looking at finding the cube root of 125, Greg, it's 5, right? Because we're looking for what times itself. But now it's not always that easy.
Oh, I have the next one.
So, fourth root of 16, Leon? 2, right? Because 2 times 2 times 2 times 2. What about the third root of 27, Wyatt? 3. All these are real easy, right? Good. Those should be easy. So now we step it up. Converting to radical form from a rational exponential form. So 12 times a to the 2/3. Now this gets tricky because what actually has the power and what isn't affected by it? Jacob?
So the a is to the power. So what you would have is 12 times a cubed squared.
So 12 times a, you mean the cube root of a?
Cube root.
And then do I put this in parentheses and like that?
Yep.
Anyone disagree?
No.
That is correct. The 12 is not affected at all by the power. So do not fall into the trap of thinking that we somehow have to use the 12. All we do is put it up front. It's just our coefficient.
Mr. Hudson, can you give me an example of a time that I will ever have to use this?
It will take too long to set up a situation. It deals with any higher level branch of mathematics. So calculus, I mean, there's even applications in trig. You guys just haven't seen it because we haven't gone that far into it. Especially like not linear algebra, but like exponential algebra and those different, the higher orders. It's just, you have to learn the basic building blocks before you can like, you know, see the house or whatever analogy you want to put to it.
This stuff
Are
would
you
be
saying
useful on
Emily is
the SAT.
Yeah, but that's not a like practical day by day. Like, I'm not going to tell you you need this for this test. That's stupid.
What
I'm
do
gonna
you
show
mean
you.
it's stupid?
So,
I know.
try this on your own. Now, 64a is in parentheses. It's all being raised to the power of 4/5. So, the first step in rewriting this is write it in the radical form. What is the root here? Anyone not Jacob know what my root is here? Grant? 5 is my root. So I set up my radical with the 5, 64a. Now, where would I put that 4? Leon?
You could put it outside the parentheses
Why?
because the notes say so. Well, no, because you're basically multiplying it, but
Well, why not put it outside?
because it's the same thing because you're multiplying itself 4 times.
I think it's neater and better to put it out like that. Jacob?
Because, well, if you put it inside, then you would have to put it on both the 64 and the A.
Yeah, we'd have to here's the other option which we're not going to use. I'd have to have 64 to the 4th and a to the 4th both in there, and then 64 to the 4th gets really messy. So I'd rather just put it out top. So is there a 5th root of 64? Something that times itself 5 times makes 64. Well, 4 times
It's
itself
not
5 times
four.
gets really big.
Yeah, it's
2.297396.
So what about 2? 2 times 2
4
times 2
8
times 2
16
times 2.
32.
So wait, it's
you
not.
add another 2, it would have worked.
4, 8, 16, 32. 2 doesn't work. Is there a 5th root of 64?
It's
Maybe
like
not.
2.7.
It's not 3.
So break it up.
2.29739670999.
Hey. Okay, I'm gonna, because you guys are just trying to use your calculator to be stupid. The more you use your calculator, the dumber you are. We just talked about 32 has a perfect 5th root, right?
Yeah.
So we take the 64 and break it so I can use that perfect root. So instead of using 64, we're now going to make this the 5th root of 32 times 2 times a, all to the 4th power. 32 now can get pulled out and become 2 in front of my parentheses. I now have 2a inside my radical. Sorry, I think I said in front of my parentheses when I meant in front of my radical. And now all of that to the 4th power.
So that's just 16.
Wait, where'd the 5th go? Oh, yeah, we already used that, right?
Oh, sorry. We did already use it, but you're right. It still needs to be written right here. So you cannot forget when you draw the radical. Every time you draw the radical in this problem, it's got to be the 5th radical, or the 5th root.
So that's just
So then the 4 applies to the 2, becomes 16. I still have a 5th root of 2a to the 4th.
I don't like how this writes it's like root thing because it looks like it's to the power of 16.
Oh, yeah. So I'm going to capture this real quick and then capture their solution form. And they went ahead and actually put their fourth power in the radical, which once we get it simplified, then we can put the power in if we want. So whether you use the method that I had where the 4 is still outside or whether you put it inside doesn't make a difference. Whether you take the power then the radical or the radical then the power.
In our homework, we need to simplify it to this.
Yeah, notice we went radical form first. They kept it rational power form. It depends on what you like. I like the radical form because then we were able to see the breakup of the 32 and the 2. They did that initially. We just had to figure out what the perfect fifth root was. Come back.
Oh, I see what they did.
Yeah, they broke up the 64 first. So, what is the exponential equation a to the 5/6 in radical form? Somebody
you want
that
an
I
answer?
haven't talked to yet. Yeah.
3 to the 10.
Oh, did I leave the multiple choice there?
Oh wait, no, I skipped ahead.
No.
It would be
You're way ahead.
a to the radicals. Wait, a to the fifth radical.
Yeah, but we have better ways to say it. You could say the 6th root of a to the 5th, right? Because if we look at this, it's the 6th root of a to the 5th. Because a has the 5th power, but it's got the 6th root. So yeah, practice kind of saying those. It's the 6th root of a to the 5th.
Okay, so don't put it on the outside.
It doesn't make a difference.
It's like the order you
So this would be the same as saying the 6th root of a to
So
the
that's
5th.
still in radical form. That's
Yeah.
all.
But this is simpler. So if we're talking about simplifying, try to write as little as possible. Everything you write makes it less simple. So this is simplest form.
What day is today again?
Monday.
Monday. How can you forget?
That explains it. When you can't remember what day it is, just go with Monday.
Well, Thanksgiving does screw everything up.
Could be true.
All right. So now we're going to take it from radical form into exponential form, which always tends to be easier for people. You use the power as your numerator. You use the root as your denominator. So what is my rational power going to be here? Grant?
Pretty sure it's B 3 over 5.
Yeah, b to the
Well, yeah.
3/5, right?
Yeah.
There we go. Try this, but be careful. We want to simplify as much as possible. And actually, bonus points if you have the steps of how we get there.
Ooh.
Bonus points meaning?
Nothing. Points as in like whose line is it anyway? Points don't matter.
Oh, that's.
So Jacob, what's the first thing that you're actually like trying to? You seem excited.
Like, so first you would split up the 27 and the D to,
Ah, yeah.
like, instead of, like, you would put a thing between them.
So if I split up the 27 and the d to the 5th, what do you mean?
Like, and then just like, so they can belong in two separate, cube roots.
Yeah, because really these are just multiplied.
Yeah. And then, so you can simplify 27, cube root of 27 into 3.
Ah, so I'm just going to write this 27 to the 3rd and d to the 5th to the 3rd, which I could have written better, but just to start, I'm just going to show that both of them are to the 3rd power. Hey, gentlemen, can we stop making faces at each other? I was hoping it would fix itself, and it hasn't. Yeah, don't try to justify it. You're just making faces at each other. 27 to the 3rd power, or 3rd root. So it's 3, right? Because 3 times 3 times 3. Then how do I neaten up d to the 5th to the 1/3?
Just multiply them together.
Yeah, I can really, my power to a power really multiplies, or Mackenzie, it becomes d to the 5/3, which actually I'm going to raise that up a little bit. d to the, so 3d to the 5/3.
Oh, I get why the 1/3 came up now.
Just like
What about this? Cube root of s squared. Well, you got the answer?
No. One second. Oh.
That is an 8.
Well, that's because he's working ahead, and all these are on the paper.
Is that an 8 or an S?
It's an S.
Oh, that's an S.
It looks
That's
so
an S.
I knew that.
Sorry, it's not tall enough to be an 8.
I actually did.
Also, that should have been on the back of the page. I don't know why it crammed on the front there. Sometimes my formatting gets weird. So Ben, do you have this answer? Because you should have it in about 2 seconds. Okay, what is it?
S to the 2 S to the
S to the what?
S2 over, yeah, I did. S, I can't speak. S to the sec, oh my gosh.
S to the power of, yeah. S to the 2/3.
That was literally scarring.
And now, where this matters, you can estimate the metabolic rate of living organisms based on the body mass using Kleber's law. Metabolic rate is like how fast you process food or nutrients. The guy who figured all this out.
Oh.
So the formula R equals 73.3 times 4th root of m cubed, or yeah, cubed. Relates metabolic rate R measured in calories per day to body mass M measured in kilograms. What is the metabolic rate of a dog with a body mass of 18 kilograms? This, by knowing your metabolic rate, like if you were really big into fitness and nutrition, that will tell you exactly how much of what foods you should eat at what points through your day. Like, you can get really, really, really detailed about what you should eat when based on how quickly your body processes it. So, body mass of 18 kilograms, well, we know that is our value for M. So we want to rewrite this with M being 18. So my R will equal 73.3 4th root of 18 cubed. Anyone think of anything like what the next step is? Leon?
We can pull out 3 to the 4th from this, and 3 squared times 2.
Pull out a what?
Oh, be 18 too. We can like simplify it down into 3 squared times 2 in parentheses cubed.
So you're saying make this 3 squared times 2
And then 2
to the 3rd.
times 73.3.
Yeah.
Wait, where did you
Because they broke up the 18. You just wrote it in. I like the little pence at the end for the first.
Yeah. 18 is just 9 times 2. 3 squared is 9 times 2. So Leon, what's your end goal here?
Wait, I turned, and then I simplified the parentheses to get 3 to the power of 6 times 2 to the power of 3 to the power of 3. Then I broke up 3 to the power of 6 into 3 to the
Hold up. 3 to the 6 times 2 to the 3rd. So power to a power, they multiply. This was really 2 to the 1st to the 3rd, so they multiply.
Okay, and then I broke up 3 to the 6th as 3 to the 4th times 3 squared.
Okay.
Then I just took the 3 out since it's a 4th root.
Is there an easier way, or do we like have?
This is just one way. We're going to go back and look at, I mean, if you don't want to solve it this way, try it on your own in a different way. 3 squared is 9. 2 cubed is 8. So 9 times 8, that'd really be 72.
Yeah. And then multiplied by, and then
Yeah, that all still has to come over and multiply by the 73.3.
I think that's 219.9, right?
I'm going to leave that set for just a second.
Yeah.
They just evaluate the whole thing. Just they do 18 cubed and then they do the 4th root of it and then they multiply. Because we know everything and there are no variables, like I like your method of simplifying based off like breaking things up and everything, but we eventually are going to want a decimal value for this since it like doesn't say leave it in rational form or radical form or anything like that. So we could honestly just start by doing 18 cubed, then take the 4th root of it, because really easier way to write this is 73.3 times 18 to the 3/4. Because this was really 73.3 4th root 18 cubed. And then that gets us that approximate, what is it?
So what did you
640.6.
Okay, yeah, that's what I got.
5, 6.
Try the next one, going with the same formula, but now we're dealing with a man whose mass is 75 kilograms.
How do you use it?
Raise it to the power of 1/3, but I feel like you're trying to do 4th root, which would be raise it to the power of 1/4.
4th root, yeah.
So what I would type in my calculator, if we want to go that method of what I'm going to write, 75 to the 3 divided by 4.
I just put 75.
Okay, that too.
You're weird, Robert.
That's so funny. I think I did
Jacob.
something right.
You should get approximately 1,868.1
What? Dogs? Cats?
Pizzas.
metabolic rate. It doesn't really have a units. You'd say the metabolic rate is, but it's calories per day to body mass index. It's confusing.
I hope we don't have to learn this.
I think that's calories per day. How many calories you're supposed to ingest in a day. So approximately 2,000 for a normal, quote unquote, normal person. Questions on this?
Ain't nobody normal.
Well, that's why I said quote unquote. So your mastery is going to be tomorrow. So I would utilize this like 13 minutes that you have right now to get some work done. I guarantee you should be able to get done with the entire front of this before you walk out of here.
I used to.
James gonna finish the whole
That's the thing now.
Yeah.
I stopped.
Is that a promise?
I have gym.
I haven't sworn.
Oh yeah, I got it. Oh yeah, swap car, swap car.
Spell car.
I'm
SWAT
not
car.
really-
It's more of a truck than a car.
SWAT truck. That SWAT thing.
That one SWAT thing.
That SWAT thing.
I
The
was
fly
joking.
swatter.
The dice water.
I don't know if
Fly
that's
swatter.